Welcome to Rod's Garage. Let me introduce myself. My name is Rod Yates, and I've worked in manufacturing for over 30 years. For the past 10 years, I've been blessed to work at the University of Southern California at Viterbi School of Engineering in the Aerospace and Mechanical Engineering Department as a senior instructional lab technician. That's a mouthful, isn't it? And that's enough about me today. Today, I'd like to show you how to build an electric telegraph device using household items. But before I do that, I'd like to tell you a little history about the electric telegraph machine. You'll have to excuse me though, I'm going to have to read this portion from my notes. From the beginning of time, people have been trying to communicate over greater distances than what their voice could actually travel, using methods like fire signals, smoke signals, flags, waving your arms with flags, and mirrors that would actually reflect the sun at even greater distances. After the discovery of electricity, wires were stretched from one point to another, and an electric current was either allowed to flow through or broken by a switch called the telegraph key. The electric current was first used to make marks on paper and later included a sounder to identify the short and long clicks to then be decoded into letters from the alphabet in the 18th century. In the 1830s, two gentlemen named Cook and Wheatstone installed the first telegraph system in England to prevent railroad trains from crashing. In America, inventor John Henry was experimenting around the same time with the telegraph machine to communicate from his home to his office at Princeton University. By the 1840s, Samuel Morse started working with John Henry along with Morse's assistant Alfred Vail to record the short and long signals with a pencil on a moving strip of paper. Together, Morse and Vail created what we now know as the Morse code, and this system has been used well into the 1900s. In the 1900s, eventually, they did discover how to send messages over radio waves, and now, to make a long story short, we have cell phones. And that's enough talk. Let's build a telegraph device. Today, when we are done, our telegraph device should look something like this. Alright, and then each section, we'll be putting three main sections together. We have the key, we have the battery holder, and then we have the electromagnet coil with the striker. All right, a few more things here. When we have this all set up and our wire system is all ready to go, this is what our electric flow, our current flow will be. So we have a battery source. It's going to be traveling into our electromagnet, and then it's going to either flow through the key or the key will actually shut off the current. This is how we create our sounds. And this is basically what your Morse code looks like. You can look this up on the internet and probably get a little bit more information about this. Alright, now let's show you what materials we're going to be needing today. Alright, so we have two nails. We could do 2.5-inch nails, but I chose to use 3-inch nails. These nails have to be a ferrous material. That means they have to be magnetic. Alright, so I'm even going to take one out and I'm going to use another device, and I'll show you that later on at the end of the demonstration. So we got one 3-inch nail. We're going to need 4 strips of metal. This metal could come from a tin can. I didn't have any strips around the house, so I actually went to the hardware store and bought some metal stripping that would actually plumbers use this to hold piping up against the walls. This is a very cheap material, but I needed 4 pieces of metal. 3 of them are going to be 4 inches long, and 1 of them will be 7 inches long. The most important one is this 7-inch long. It needs to be ferrous, but I just happen to have all 4 of them that are magnetic. Alright, so we have some metal strips, nails. Okay, I have 10 screws that I put into my blocks of wood. Oh, by the way, I need 2 blocks of wood. And then again, I have 10 screws. I have set everything up here to where it's going to make it a little easier for me to move it along. I also, as I set this up, I drilled holes in my wood so my wood wouldn't split and it would be easier to put my screws into it. We need wire. So the best wire that I found that works with this is speaker wire. So you might want to ask your mom and dad if they have any old speaker wire laying around the house. You'll need about 25-26 feet of this. Speaker wire usually comes when it's connected. And let's see, speaker wire usually comes connected and it's insulated to where the two wires are together. So what we need to do is split this wire apart from each other. And my fingers are getting in the way here. So you see what I did? I separated these two wires. And now I'll only have one strand of wire, about 24-25 feet. Alright, I have all that already measured out for us later on. We'll also need, we'll need some tape. I have a couple other small nails. And these are the tools we're going to need. We're going to need our wire strippers, a knife sometimes comes in handy when you're having to split the wire, a screwdriver, some shears to actually cut the metal, and I found that a pair of pliers helps you as I'm trying to bend the metal, and you'll need a hammer. Alright, I think I went over everything that we are going to need to get this started. So let's build a telegraph. Alright, first thing we're going to put together is our key. So our key, you'll see that I already have all my pieces made. And oh, wait a minute, there's something black on the end of it. Well, I put this black tape on the end of it so I keep myself, I don't cut myself. I'm also wearing my glasses for safety. It's very important to have the proper personal protective equipment. That's called PPE. So let's start building this thing. What I'm going to do, I'm going to put all these pieces in place. After my pieces are all in place, I'm going to wire this all up and put the batteries in, and then we're going to have a nice working telegraph machine. First, I'll need my screwdriver. I have a very handy screwdriver. It goes from Phillips to a flathead very easily. And we'll get these out. So you'll see I have two screws at one end here and one at the other. These two screws are going to hold my key in, and the other one is where I'm going to be striking down on top of. This is where it's going to be making contact and it's allowing the electricity to flow through or breaking the electricity. So let's put this in place. I'm not going to tighten these all the way down because I have to hook wires into this once I get everything in place. Alright, that's ready to go. Next I'm going to put the battery holders in. So on the battery holders, it's very important the direction these batteries are going to be going. And before I even did this, I put these two batteries down and I measured where my pieces were going to go. Also, you'll notice that the battery has an end that sticks out. That'll be your positive end, and the little flat end, that's going to be your negative end. Each battery has 1.5 volts, and when you put two of them together, you got 3 volts. Alright, and that's what it's going to require to actually make this device work. This is what you put in your flashlights. So you should have some of these around, or you can also use the AA batteries. Now you can see the AA batteries are a lot shorter than the D batteries by about 3/4 of an inch. So I'm using this strap wire for a reason, because I can adjust it back and forth. I'll show you this later. Alright, let's put our battery connectors in right now. And again, I'm not tightening everything down, I'm just getting things in place. And once everything is in place, I will start wrapping my wire around. So I had a lot of different types of screws here. Some are Phillips and some are flatheads. So you might need 2 different types of screwdrivers. Alright, get that in there just in place. You see, I like using hand tools. I just prefer to use hand tools. It's old school, and then I can feel what's going on. Sometimes with power tools, you get carried away and you tighten things too tight, strip out screws. I prefer to use the old ways. It works for me. Alright, there we go. Battery holders in place. It's gonna be holding those batteries, something like that. So adjust a bit. You see, this metal bends quite easily. I'll show you a little bit more about this later as we make sure. It takes a little bit of adjusting to make everything work once we get it all set up. Alright, we have our key, we have our battery holder. We're missing something big. Oh, here's our electric coil. I've already made one today, but I'm going to show you how to make a new one. I already have a piece set up. So here's what I did with my nail. I put a little disc made out of wood at both ends, and that way as I wrap the wire inside, it keeps the wire from separating and coming off the ends. It makes a better magnet at the end of the day. So we're going to put this in my vise, and I'll show you how to start this wrap. And what I mean wrap, I mean we're going to wrap wires. And I don't think you want to hear me wrap. It's going to look something like this when you're done. I've wrapped this 135 times, a little bit more than 100. And you can see I have wires coming out one end, wires coming out the other end. I've taken the insulation off of my wire, and about an inch, a little bit more than an inch at each end. I've taken the insulation and I twist the wire to make it easier to work with and to tighten down onto. Let's set the electromagnet into our piece of wood using a hammer. There we go, set. Alright, now all we need to do is make our sounder here. Alright, let's get these out here. So these 2 screws that are going to be holding this piece right here, it's called the sounder. These 2 screws don't really connect to anything. They're just going to be holding this piece of metal down. So let's get this in place. And then we can start hooking up our wire. So these 2 I'm actually going to tighten down all the way. Alright, so this is all set. So what I'm going to do, I'm going to start connecting everything. So it's very important in the direction that these batteries go. You'll see that the D battery, positive end, and the negative end has a little thing that sticks out, and then we'll put the 2 together. I've already set the distance earlier today, so what we're going to do is just start hooking this wire up, and we'll try and get this device working as quickly as possible here. Alright, so earlier today I took another piece of strip. So when I separated my wire, I actually stripped off an end here earlier, so I need another piece. So I'll show you how I strip off the end here. And so that was actually quite easy. So it looks kind of like that, and then you twist it a little bit. Alright, so you see how much easier that is to work? Be careful, I just poked myself. This is copper wire, and it, you know, it can poke you a little bit, so be careful with it, alright? Alright, so now I already have one ready to go. So both ends are cleared and ready to connect. So I'm going to put one end on the negative end. Again, the positive end, the negative end. I'm going to hook this separate wire to this negative end on the battery holder, and it's going to go to the back end of our key. Just take your time, make sure all your wires are connected really good. It's very important to make sure you have good connection to all of your metal. All of your metal has to be connected really good to the wire. Alright, so now this end is supposed to go into where I strike my key. Almost done here. We're almost ready to strike this thing up. Alright, that's all ready to go. Now I'm going to adjust this and tighten this down here. Oh, actually, so now we have the negative end from the battery holder is going to go to the back end of our key. Make sure all your wires are connected, making good contact to your metal. Alright. So let's bring that just at the right spot. So it takes a little bit of adjusting. So it doesn't have to be pretty, it just has to work. Alright, see, tap, 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 tap. Alright, so now we have the negative going to the back side of our key. We have our electric coil to our actual striking, where our key strikes. And we have our sounder up here. Our sounder has to be just set just right to where once this thing is magnetized and we strike down here and create the flow, this will draw down. We also need to put another piece of wire here. This is where they told me to use my second nail to actually stop my sounder from coming too far up. I decided to do it with another piece of wire. It's a little stiffer, and I screwed it into the side. It's a little bit easier to adjust than a nail. So you can get creative with this as long as you still have all the same basic components. Alright, we'll get this into place and we'll get things adjusted. We'll put some batteries in there and we'll test this thing out, huh? Alright, so again, I want everything adjusted just right to where there's just enough space to draw it down, and when it comes up, I want it to touch this point right here. The most important thing is how this is wrapped. When it's wrapped very, very tight and it's looking something like this, you'll have a good flow for it. So, and again, this actually is making me want to wrap and help you remember how to do this. So you'll have to excuse me on this one. I'm not used to wrapping, but if you don't wrap the wires tied around the nail, your electric magnet just might fail. Again, if you don't wrap the wire tied around the nail, your electric magnet just might fail. So again, keep that nice and tight and you'll have a good electric magnet. I think we're ready to go here. Alright, so let's put our batteries in. Negative end, positive end. And negative and positive. So we make sure that these are all making really good connections. And you'll see that my batteries they don't want to stay in place. So I've actually added a couple more smaller nails just to keep this from moving around too much. I'll show you another method later in just a minute. Alright, and that's ready to go. So there's also one more little trick here. It looks like we have good connection there, good connection here. But just to make sure, I have some rubber bands here. And these rubber bands are going to go from one end to the other. That way it makes sure that these two connections stay tight. Alright, you see how that works? I do believe we have an electric telegraph machine. Let's see if this thing works. Alright, there's going to be possibly a little adjustment here. Oh, I can see it wants to work, so not quite close enough. Alright, there we go. And see how it draws down, and then it goes up. I'm stopping it with this other piece of wire, and it draws down, and it goes up. And there you go. You have an electric telegraph machine. So here's how you use the Morse code. It's dot, 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 dash, 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 dot, dot, dot. That's the international signal for help. All right, and that's a telegraph machine today. Thank you for joining me on this with my little project here. Wait a minute. I forgot to show you the AA batteries. Let's do that before I leave. Alright, let's take this apart. Take the nails out. I almost forgot. I was telling you I was going to do this and I almost forgot. Alright. Now we have the AA batteries. Oh, wait a minute. Look at that. They don't fit now. Here's what we can do. We can bend my metal like I told you I could earlier. Alright. There we go. That wasn't hard, was it? But to make sure we have these at the right angles and fit right, I'm going to use my pliers. Because my fingers just don't work well bending the metal at the right point. Alright, so we have one in there, and we have one there. Alright, so that's close, but this time I don't want to use nails. I would like to use a little bit of tape this time. And we're going to take this first one down, making sure it's pressed up against that piece. See how I press it up against real tight? Alright, and then we're going to do another one. We're going to force this in here. Actually, I want to get that down there. Alright. Tape. Right. I have more problems with the tape than I do the nails. Alright, there we go. Looks like they're connected well. Alright. Let's see if the AA batteries work. Well, by golly, it does. Just like I thought. So as long as you have the 1.5 volts and 3 volts included when you put two batteries together, you can do the same thing. So again, dot, 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 dash, 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 dot, dot, dot. I'd like to thank you for joining me on Rod's Garage, and we'll see you next time.